Alright, so in this part of the video, we're going to be buttoning up the bottom half of the engine. That's going to be the oil pan and the oil pump. That's really all we have left down here. But before you can put the oil pan on, you need to have your rear main seal and timing cover on, because those two corners, the two ends of the oil pan actually seal onto those two components. So we're also going to be installing the camshaft, the timing gears, the timing chain. Our water pump drive gear needs to go back on so we can get our timing cover on. Then the rear main seal is pretty simple. I'll show you how to do that. And then once you have all that together, you can put on your oil pan and windage tray, and your oil pan will be ready to go on. And then we'll move on to the heads and the top end after that. I know there seems like a lot to the reassembly process, but it's because there is a lot to the reassembly process. Disassembling it, it's like a bunch of Legos. You're just pulling pieces off, you're unbolting stuff, ripping parts off of it. But reassembly is not the same way. There's really a lot of specific details that go into reassembling, and if you don't do everything perfect, you're either going to have a leak, you're going to have broken parts, you're going to have metal getting into the engine, and things are just going to go wrong. You're going to end up having problems. So it's really important to follow all of those very, very specific steps. And my goal here is to save you guys a lot of time that I wasted by finding out these things the hard way by making these small mistakes. There's going to be tiny little things you need to pay attention to so that you don't have problems in the future. The key to having no leaks on an engine rebuild, where you're using old parts, you're not like buying new pieces like this, like everything is already came off the engine. It needs to be super, super clean. This is where the oil pan gasket is going to seal, especially in these corners right here where it's just an easy pathway for oil to leak out. Everything needs to be super, super clean in order to get it to seal correctly. And then along with that, I'll show you some other tricks that I have found in my research, and from my experience of having lots and lots of oil leaks, I finally found some really good ways to make sure that you will have no leaks. So stay tuned in this video to see how I install my oil pan and how I clean this up so that I can make sure that there is no leaks. So we're putting on our rear main seal, and as you can see on the back of the crankshaft here, this little cut mark in the crank, that's from the machine shop where they grab onto the crankshaft to spin this thing so that they can grind it and they can balance it and do all of that. Now that's nothing like major, that's not going to affect anything, it's still going to seal just fine. But if that groove is really deep, you have to get one of these micro sleeves. Basically it's just like an oversized bearing sort of thing, and it slides over your crankshaft on the back here, and it's basically just like a repair sleeve to fix that groove. That way you won't have any spots for any oil leaking. But I actually don't need to use this. That groove isn't even really noticeable at the fingernail even, and so that's gonna be totally fine. So putting on this rear main seal, I first cleaned all the mating surfaces of the machine part of the seal. Then I put some of this Permatex high-tack gasket sealant on the back side of that gasket. Go around and press down all the edges, make sure that it's sealed all the way around. Anytime you use a paper gasket, this stuff works really, really well just to help seal it. It doesn't actually like harden, it just like stays really sticky. So you'll see me using this a lot, putting this engine back together. So now I'm gonna get it on this side of the gasket. Just like a nice light coat, just make sure it's all covered. Doesn't need to be on heavily or anything. Lube your rubber before you slide it on. Just a little bit of oil in there. Now we're installing it on. This side of the mating surface is also super clean. I have my high-tack Permatex on this side of the gasket. The reason why my engine's on the ground is because this stand was in the way, so I actually had to drop it off the stand just to get this on. And then, I'm just gonna go ahead and slide this baby on. Make sure that the rear main seal doesn't fold over the crankshaft. It's a little bit hard. So I had this little bike tube installation tool to put like a little tire iron for a bike tube, and I used that to grab the rear main seal and go around it so I could get that lip to go over the crankshaft. It's a little bit tough. It might have been better in retrospect to put this metal piece on first and mount it, and then slide the lip of the seal over the crankshaft and then push it into this hole, rather than installing your rear main seal first. That way the rear main seal isn't like squeezing the seal from going over the crankshaft, and it would just like go over a little bit easier. So next we're going to be installing the camshaft. It's always good to wipe off your bearings with some acetone or some lacquer thinner, but obviously it's pretty impossible to get all the way down inside of there to clean all of them. So I'm just kind of using my flashlight, looking in there, making sure there's no noticeable debris. The cool thing about cam bearings is they're very much more forgiving than the crank bearings. Like if there's like a little bit of debris in them, or like they have scratches on them, you can even see this one, it's got like machine scratches all around it. They're very soft, they're very forgiving, and so if there's a little bit of lint in there, then you're okay. As long as the block was cleaned from the machine shop and you made sure it's clean when you got it back before you reassemble everything, then it's going to be okay to just start putting that camshaft in. Got your selfie stick? So when you're installing your cam, you really just want to go a little bit at a time, lubing the lobes and the main journals or the main bearings with assembly lube as you go. That way you can kind of inspect everything, make sure it's all clean while you're running the cam in. You're going to kind of twist and turn to get the lobes to clear the bearings as you go. And one key part to lube is going to be that gear that drives the oil pump or the distributor. If it's a small block Chevy, they all have those little gears on the back of the camshaft. So make sure that you get assembly lube on that. You don't need an excessive amount, just make sure that it's thoroughly covered. Also, when you get to the end of the camshaft here, you can put some long bolts. You can just use the cam bolts that are used for the retainer. Just use something so you have like a little handle to grab it. And it shouldn't take any excessive force to push this thing in. If it's not going forward, it's because one of the lobes are catching somewhere along the lines. It's a little bit heavy because you don't have a lot of leverage on those bolts, but I'm kind of like lifting up like that to get it in that last little bit. And make sure it spins in there good. After the cam's installed, just wipe it off, make sure that this is super clean. There's no dirt on there, because this is actually going to be spinning behind the cam retainer plate, and you don't want any dirt or debris. Now we're going to install the cam retainer plate. I got a new one. They're fairly inexpensive, like 15 bucks on Summit Racing. You can reuse your old one, but mine obviously got pretty messed up. Something wasn't lubricated properly, so it ended up digging into the retainer plate. The cam gear ended up getting ruined. So I'm replacing this retainer plate, but you should be able to just reuse your old one. Put a good amount of assembly lube on this retainer plate, both sides. If you don't do this, then your retainer will end up like my last one. Go ahead and slide that onto the cam. Put a little bit of red Loctite on the bolts. That was way too much, but it's okay. That's enough. Torque the bolts to 108 inch-pounds. We're going to start by installing our crankshaft gear. You're going to want to put it on your woodruff key so that you can make sure that it's aligned properly. As you probably know, these are really easy to lose because they're so small. So if you need them, they're fairly inexpensive. We're just going to go ahead and set it into that second groove there. So you're just going to put one end in like this. Kind of try to get it in there as far as you can. And then I'm just going to slightly tap on this right here. Very, very lightly. It doesn't take a lot. And it's just going to rotate in there. You want to try to get it flat so that the gear will slide over it properly without damaging it or the gear. As you can see right there, it's very crooked. So that's about what it's going to look like sits pretty far down in there. Turn the oven on broil so we can get that crank sprocket in there, get it nice and hot. We want that thing nice and hot and help us expand it so that we can get it to the crank hub easier. Use some WD-40 to clean off your crank snout. It's also going to act as a lubricant to help us slide that sprocket on a little bit easier. Once that sprocket's hot enough to go on here, we're just going to give it a few more minutes. I'm going to use this pipe wrench and a dead blow hammer because it fits over the snout just barely, and it's going to drive that sprocket on. Now the other way to do this is to use a sprocket installation tool. It's basically like a press that presses the sprocket on. It's definitely a safer way to do it. I just went to 7 different AutoZones. All of them said they had it on stock, and when I got there, they didn't. So I'm just going to use this method. It's totally fine as long as you're not like wailing on this crank. You really don't want to beat on it because you could hurt your thrust bearing. But as long as you're lightly tapping it on, and the sprocket has an easy time going on, then it's not going to hurt anything. Just like before when we centered our thrust cap, we had to whack the crank forwards and backwards. It's not going to hurt anything as long as you're not hitting it too hard and you're not beating on it like I said. So that's the way that I'm going to do it. It's up to you how you want to do it. If you want to go get a press, I recommend it. But if you just have like a big socket laying around or a pipe like this, this will work too. When your sprocket goes on, you'd think that it would butt up all the way against this flush part, but it actually won't. So if you have this little gap behind your sprocket, that's actually okay because that little lip right there is going to stop it from going on any further. So just put it on as far as it will go and that'll be fine. Make sure that the dot is facing outward on the sprocket or you're going to hit yourself. Whew. She's hot. Gently tap it. See, it's barely taking anything. You'll hear it bottom out right there. See how it's not going any further? That's all it takes. There's just a little bit of a gap. Before you put your cam gear on, install this water pump drive gear. It's going to go behind that cam gear, and be extremely careful with this. I actually looked online to replace this just because I have a new timing set, so I figured it'd be good to replace this gear, and they're discontinued. Good luck finding one of these if you break one. If you do absolutely need one, I'm sure you can find them on eBay or somebody's selling some used ones. Go to Facebook Marketplace, KSL maybe, if you're really lucky. And maybe you'll be able to find a used one of these, but they do not sell these anymore. Just inspect the gears, make sure that none of the teeth are broken, make sure it's not like excessively worn, and it should be totally okay as long as it's not damaged. If you need a new bearing, you actually can buy bearings like this and then press them on, but luckily my bearing's still in good shape, so I'm just going to reuse this. To install it, I'm going to put the drive shaft from the water pump on this gear here and use that to tap on it. I set it down in the hole. Get it squared as center as possible and just very lightly tap it in. Be very careful with this piece. Once it lines up square, it'll start going in a little bit easier. Just don't tap too hard on it. And you'll hear it bottom out like that. The bolts on the front on the retainer are flush with the block. Now I can bolt it down. Put Loctite on these ones too. Just get them snug. Okay, now you're ready to install your cam gear. Just gonna put some assembly lube on the back side of this gear. Make sure you get a good amount on there. Oop. Spread that around. Just get it on there. Okay. Now we have our dot on our crankshaft facing directly towards the top. Our piston on cylinder 1 is at top dead center. And then line up the dot on the camshaft gear with the dot on the crankshaft gear, and make sure that your cam dowel pin is to the right, 90 degrees to the right. And then we'll go ahead and just put that chain over there. It's a little bit off here. Gotta move my camshaft down a little bit. There we go. And that's what it looks like when it's off a tooth. It's very noticeable. The water pump drive gear needs to line up so the cam will slide on all the way. And then our dots are lined up, dot to dot. Don't put your Loctite away just yet. This is probably the most important one because these are going to be spinning. And then torque these ones to 18 foot-pounds. Install your retainer. I went with the single roller timing set just simply because they're way more simple to use. When you do a double roller timing set, you actually have to machine the timing cover, and the double roller cam sprocket doesn't come with the spline on the back of it to drive the water pump drive shaft, so you actually have to delete the water pump as well. And if you do that, you have to go to an electric water pump. Now, electric water pumps are great, but the problem that I see with it is that if you're running an electric water pump, it's not going to flow as much water through the engine at higher RPMs. And my goal of this engine is to rev it to a high RPM for a long amount of time. So if I'm running an electric water pump, I'm going to run out of coolant flow at that high RPM, and I could have overheating issues. The other problem is I want to be able to drive this car across the country, and if an electric water pump goes out on you, it's not going to give you any signs before it does. It's just going to bite the dust on you, and you're going to be dead in the water, stuck in the road until you can go to a local parts store and swap out your water pump right there on the spot. However, with a mechanical water pump, they will actually start leaking. The seals in them will go bad, and then the water pump will break down on you. So you'll at least have some kind of indicator to know that you can get home. But obviously an electric water pump would be pretty sweet, because when you're done doing a road race, if you're drag racing or something like that, you can shut off the car but keep having the coolant flowing through the engine so that it doesn't just sit there and heat soak. So there's advantages to both of them. It just depends on what you're trying to do with your build. For me personally, an electric water pump is just not ideal. So do a search on them. There's hundreds of forums about electric water pumps, and there's lots of great ones out there. Just in my opinion, for the build that I'm trying to do, it's not something that I want. So that's why I stuck with the single roller camshaft chain and timing set, because it's going to be plenty strong for the engine that I'm building. If you're running like way high lift on your cam and you're running like over 7,000 RPM, 600-700 horsepower in that range, maybe you're going to need a double roller, but single rollers are very, very strong still. So don't believe everything here on the internet. A lot of people say if you do a cam swap, you got to do double roller timing set. Not actually true. That is not actually necessary. Should you degree your new cam? The simple answer is yes, it can never hurt to check, but it isn't absolutely necessary to degree the cam for the engine to run efficiently. Comp cams grinds most of their high energy, maximum, and extreme energy cams 4 degrees advanced. The position of the camshaft is for the best street performance. However, to assure maximum performance, it is recommended to degree the cam. The purpose of degreeing a camshaft is to correct the errors and tolerances in the machining processes of the engine that can affect camshaft timing. CompCam suggests the intake centerline method is the most simple, quick, and efficient way to degree a new camshaft. If you search Pete's Garage on YouTube, he has a video about degreeing a camshaft, and it is by far the very best way to degree a camshaft, the most simple and effective method, and it doesn't take a lot of tools to do it. The machining on the camshaft is obviously supposed to be perfect, but there are always errors in quality control and things can go wrong. For example, if this dowel pin is moved a couple degrees to one side or the other, it's going to advance or retard the timing. And that can actually cause a lack of maximum performance, or your valves might open at the wrong time and hit a piston. So it's super important to check the installed centerline angle on the cam to make sure that the machine work was done properly. Another thing that can go wrong is if these Woodruff keys are in the wrong spot, then this gear will be clocked in the wrong way. Also, the gears could be machined wrong, the chain could be too small, too tight, the chain could have defects in it. All those kinds of things factor into making a camshaft advance or retarded too much. And so it is really important to make sure that the machining is done properly, but it's not absolutely necessary. We're going to install the front main seal and the cam seal now with this vise right here. They're best to press in. If it's already on the car or if it's already on the engine, you can just set it in there, use like a block of wood and just kind of hammer it in. But obviously it's better to use some kind of press. So make sure that the inner part of that is super, super clean. And then I'm just going to put it here in my vise. I got a towel on that side so it's soft against that mating surface of the timing cover. And then I'm just going to try to press it in with my hands as far as it will go. This seal came pre-greased from the packaging. Now I'm going to use this block of wood in here to press it in as straight as possible. Basically just crank it down until it's flush. Got a little crooked there. Just gonna turn it. And there you have it. Just make sure that it's super flush and even all the way around. 1 down, 2 to go. My vise isn't deep enough to line up with that seal there. It won't go down far enough. So I'm just gonna install that one once it's on the engine with a block of wood and just hammer it on. All right guys, we're finally ready to start sealing this thing up. Just take your timing cover, make it super, super clean. Go around all the edges with some lacquer thinner, clean up all the edges. I even went in and cleaned out this groove with a wire wheel just to make sure that everything's gonna seal good. And then take this high tack and we're just gonna go around the whole surface with a light coat of it. It doesn't take a whole lot, and try not to get any of it in any of the holes. Put a coat on the gasket as well. Try to be as quick as possible with it. And then now we're just gonna take it, set it onto our timing cover. Line up all of our holes. It's very sticky. This stuff is great to seal like all the grains in the paper on these gaskets. And then once all the holes are lined up, just go around and push the gasket down. Push it all down onto the timing cover, make it all sealed. Now clean off the block surface. I'll put a light coating on this side as well. Again, careful not to get it into any of the bolt holes. Of course, do the same thing on this side of the gasket as well. Now you just take your timing cover, line it up with the dowels, carefully press it on, and then I'm going to go around and push all those surfaces to make sure that all that high tack squeezes together. Torque these to 100 inch-pounds in a cross pattern, just going back and forth. You can also just use regular RTV or the right stuff to seal these timing cover gaskets, and that'll work just fine too. RTV breaks down with oil, so the right stuff is always a better replacement to RTV. Take a measurement of the gap between the crankshaft and timing cover seal and make sure that it's the same on both sides and the top and bottom to make sure that your timing cover is centered. Otherwise that seal isn't going to seal properly around the crankshaft. You can also install your hub to make sure that it's even all the way around, but the hubs are pressed on, so it's a little bit of a pain to get that on, take it back off, so I'm just going to measure with this micrometer. All right, once you got your timing cover on, it's a good time to check the camshaft end plate. You actually have to have the cover on because it acts as a stopper plate for the camshaft on small block Chevys. So I got my dial indicator hooked up here on the front of the cam. I just have the pin touching the dowel pin right here. That way I can get an accurate measurement of how much it moves. And all I'm gonna do is pry the camshaft all the way toward the back using that lobe down there that's sticking up. Just pick one of the lobes that are easily accessible and pry it all the way toward the back. Then calibrate your dial indicator to 0. And now I'm gonna pry the camshaft forward and see what measurement we get. Jumped up about 6.5 thousandths of an inch, which is right in clearance. You want anywhere between 5 and 10 thousandths of an inch. All right, next we're gonna install our camshaft distributor seal. In my case, I don't have a distributor, but just get it pressed in there a little bit, and then just put a 2x4 over it because it's flat. And we'll go ahead and drive it in. Check it to make sure, see how it's walking in. So I'll kind of err on this side a little bit. It's starting to go in straight, so I can keep going. Okay. All right, now that it's all the way in, just gonna go around it and make sure it's flush. Now we're gonna install our water pump drive seal. You don't need one of those fancy tapered tools to get the lips of the gasket onto the water seal. You can just use this drive shaft for the water pump. It actually comes with the engine. I just got a light film of oil on there. I'm gonna push this in here, kind of crooked. Just get it in there without folding in that outer lip. Oh, I folded it. It's really tricky to get it on there properly. What you're looking for is for that yellow ring to be folded outwards and the black ring to be folded outwards. They both have to fold outwards like that on both sides. Now you can just go ahead and install it onto the shaft. Make sure it's pressed on all the way. Take a bigger socket and place it over the top of that one. Now just simply press it in. Don't forget to replace this little O-ring while you're here. Brand new one just from GM. Specifically made for this piece. I just want to talk about these oil pressure springs for a second here. A lot of people think that when you upgrade to a high pressure spring, it's just going to give you more pressure, but that's not necessarily true. The function of this spring is basically when the oil gets sucked up into this pickup tube, it comes in through this pickup tube and it pushes it through a check valve and through this hole right here. Now at first the check valve is pretty much closed, and so you're not getting a whole lot of oil pressure through there. Now as the RPM increases, the oil pressure is naturally going to increase because you're pushing more oil through. But also as the oil pressure increases, this spring is going to compress until the check valve fully opens and it allows full pressure to come through, or full oil flow to come through. Now the more flow you have of oil, the less pressure you have. Just like when you put your thumb over a hose, it creates pressure. When you remove your thumb, it allows all the flow to come through and the pressure drops. So if you get a high pressure spring, what that does is it blocks that checkoff valve for a higher RPM. Basically, with this stock spring in here, it will only hold to 58 psi. So as soon as your oil pressure reaches 58 psi, that oil check valve opens all the way and you're getting the full flow of oil through this oil pump. If you upgrade to a high pressure spring like I did, I got a 70 psi spring. Basically what that's going to do is once the oil pressure has to reach 70 psi before the check valve opens. That way the oil pressure will actually reach 75 rather than just being capped off at 58 psi. And the rule for oil pressure is basically 10 psi for every 1,000 RPM. So every time you get 1,000 RPM, you want another 10 psi. So if you're at 6,000 RPM, you want at least 60 psi. And if I'm going to rev this thing to 68 or 7,000 RPM, I want 70 psi of oil pressure up there. And that's never going to happen with this stock spring because this will only allow the pressure to reach 58 psi. With the other spring in it, it's going to allow the pressure to get to 70 psi before that check valve fully opens. So in conclusion, all these springs is a pressure regulator. If you want more oil pressure, that is achieved with a tighter bearing clearance or a higher volume pump. But you have to be careful with high volume pumps because if you're running a stock oil pan and you don't have enough oil in that pan, then all the oil is going to get pushed to the top of the engine and the bottom of the pan is going to get sucked dry and it's going to ruin this oil pump. So to replace the spring, you just first start by removing all 4 of these cover bolts holding the oil pump together, because we need to drive this pin out and the pin's covered on the inside of the pump. We can only get to this side. So remove these 4 bolts. Then you remove the cover. I'm just using a pick tool so I can punch this pin out of here. You can use a punch too. So once the pick goes through, it's kind of acting as a holder for that spring. Now I'm going to carefully move the spring with my thumb over it. And then the spring only comes out about that far. Pull the old spring out. Put the new spring back in with the big side facing towards the bolt. Use another pick tool or screwdriver to basically just hold it down while you put in your punch. And then once that's through, you can push this pin in place of it. And I'm just going to start to hammer that in as I remove my pick. Now I just got to put the oil pump back together. I'm going to put a little bit of assembly lube on this since I have it apart already. Put a little bit of red Loctite on these ones. And then just snug them down real good. Nice and tight. Alright, we got our spring in there. Now let's install this thing. First off, when it comes to oil pumps, make sure you get one of these quality drive shafts. The regular drive shafts come with a little plastic coupler right here that slides onto this oil pump, and it just like creates a bunch of slop and wiggle room, and it's just gonna end up wearing out your pump and wearing out the drive shaft, and then you're gonna end up having problems down the road. So just get a high quality one of these. This was like 15 bucks from ARP, or you can order it from Summit Racing. So we don't really need that shaft on there just yet because we're gonna be uninstalling this. What we're gonna do is first we're just gonna set it down on here and bolt it down. If it doesn't go on perfectly smooth, like that one just went on super smooth. And when you put this on, you want it to line up with the dowels perfectly and go on super smooth, just like that. It basically just dropped right into place. If not, you can actually hit these dowel pins with like a punch, and you can smack them to the side. You want to use your micrometer to measure the distance between the dowel pins and the distance between the holes, and then make adjustments necessary. Because if you have to like hammer this oil pump on and it doesn't go on just like that, then you're gonna put a lot of tension in the cast right here, and it can actually end up cracking because of the heat that it's gonna see. So once you have it on like that, we're gonna install our pickup tube. I only wanna get that in there so far because I'm gonna need to take some measurements to make sure it's from the right distance from the bottom of the oil pan. And if it's not, and I beat it on all the way, then well, I'm gonna have to beat it off, and I just don't wanna have to do that right now. So you only want to put it on so far so that we can measure the distance between the bottom of the pickup tube to the bottom of the pan. It needs to be about 1/4 inch to 3/8 of an inch from the bottom of the pan. Too close or too far can cause a lot of problems, and if that's in the right position, then I can beat it on the rest of the way, and then we'll actually remove the oil pump again, put a tack weld right there, and then we can finally mount the pump. So I'm using this ruler as like a straight edge to measure how high up the bottom of the pickup tube is from the bottom of the block, so that way I have kind of a straight edge here. And obviously, as you can see, the oil pump is tilted, so I want to take my measurement from this side. It's about 7 3/4 inch away from the bottom of the block. Now I have my oil pan with my gasket set on here, that way I know the distance it's going to be. And then I'm also going to take this measurement from the bottom of the pan, about 7 3/4 of an inch. So we're too close to the bottom of the pan. It's going to be too close. We're going to need to move this pump just barely away from the bottom. Ooh, that was too much. Lucky for me, I was able to put the pan on with the gasket and everything. I haven't torqued it or anything. I just have the corner bolts in, and I have this drain plug here that I can see in, and the plug for the oil level sensor is right here, so I can shine a light in here. So if you take a look inside of there, can actually see right there where the pan, where the pickup tube is, and it's looking perfect. There I can just do like a visual test just to make sure that it's not touching the bottom of the pan, but it's also not too far away. Obviously our measurements are going to be more precise than just eyeballing it, but we can get a good idea that that's in the right place right there where it's at. So now we got our pickup tube perfectly in the right place. I'm going to finish hammering it on, and then we're going to put a tack weld right there because it's press fitted, and there's nothing else holding it on. Fortunately, these pickup tubes have this little bracket right here so that you can just bolt it on with the oil pump. But unfortunately, if I set it right there, it's not going to be close enough to the bottom of the pan. So funny enough, it actually sits just barely right above that bolt. That ended up being a perfect measurement. So now that it's right there, I'm going to hammer it in the rest of the way, and then I'm going to put a tack weld right here to keep it from sliding out. I've also got this towel here to protect anything from falling into the engine because this aluminum stuff tends to kind of flake off. I know it seems kind of stupid because when I hammer this in, some of it might flake off inside of the oil pump. Unfortunately, there's not really much we can do about that, but this is how people put these on all the time. So I'm just gonna hammer it on and hope for the best. I'm no welder, but as long as you got some kind of tack weld on there, I even put one down here by the bolt to make sure that this pickup tube isn't going to go anywhere. We're ready to install the oil pump finally. I got this drive shaft from ARP. It has this nice metal coupler on it. The one from GM that these pumps come with is this plastic one, and basically it just kind of sits on the end here. It acts as like a wobbly in a way so that it can keep the drive shaft from being at an angle or falling off or anything. But these are super cheap and brittle, and they're plastic, so I'm ditching that one, and we're just going to go ahead and use this one from ARP. Just clips on right here, just like an extension. So you just slide that guy down in there. And you don't need any gasket or RTV or anything on here. GM just puts these on totally dry. Metal on metal. Torque this one is 66 foot-pounds. Alright guys, we have our oil pump installed. Our pickup tube is set and it's adjusted to the proper depth. We have our drive shaft installed. We're going to have to torque that drive gear on the top when we flip the engine over. But now we're ready to put the oil pan on. Cleanliness is key when it comes to mating surfaces on gaskets, because if anything is dirty, you're going to create a leak path and you're going to have an oil leak. So make sure that all this is super clean. So depending on what the block looks like on your engine, which in this case with this LT1, the mating surface for the gasket is not on one plane all the way around. In other words, it splits off right there and goes into a second piece. Same thing on the back here, the rear main seal is separate from the rest of the mating surface of the block. So in those little corners there, and in that little corner right there, we want to put a little bit of RTV because that's going to be a path for oil to leak. I'm using some of the right stuff. It's a little bit different from RTV because this does not break down with oil, where RTV does. Just a little bit. And then it's always a good idea to put a little bit back here where it's going to want to create a leak. Just like that. I'm actually going to push that in there with my finger just like that. Push that down my finger there. So we're just going to carefully lay our gasket on here. Careful not to touch it on any of the oily surfaces. And then in these corners here where we just put that RTV, we want to make sure that we're lined up here nicely. And then I'm just going to push down in those corners. Push down here in these corners. Now we're ready to set our pen on here carefully. And I'll push down. And you definitely don't want to over torque these. I'm just going to run them down at first. We're going to torque these to 15 foot-pounds. We'll go back and forth until we kind of creep up on it. Now we'll go to the other side. Get these corner bolts down. All right, I'm going to torque these rail bolts to 106 inch-pounds, going in a circular motion around the pen. And I'm going to go around it like 5 or 6 times because these are going to keep moving as I go around.